Our next sample problem looks at predicting the effect of a change in volume. And again, volume and pressure are inversely related, so we can talk about either volume or pressure on the position of an equilibrium. And one of the things that's important to think about is changes in volume and pressure will only have an effect for reactions where the change in the number of gas molecules from products to reactants is not equal to 0. So if there's no net change, if there's no preference for one side of the reaction versus the other based on the number of gas molecules, then pressure and volume are not going to have an effect. So these questions ask, how would you change the volume of each of the following reactions to increase the yields of products? So we have to understand that when we say increase the yield of products, what we really mean is we want the reaction to shift to the right. So for each of these, we're going to need to evaluate, are there more gas products on the right as products or the left as reactants, and then change the volume accordingly to favor that side of the reaction. So looking at the first one here, we've got solid calcium carbonate decomposing to calcium oxide and CO2 gas. In this case, for problem A here, in problem A, the delta N for gas molecules is equal to +1. We've got 1 mole of gas on the right, no moles of gas on the left. So in this case, we'd like to, and this asks us to change the volume, we want to increase the volume. We want to give more space for these gas molecules to accumulate. If we were to squeeze on this reaction by changing the volume and making it smaller, we'd actually disfavor the formation of gas here. So in this case, we'd like to increase the volume. Again, I could ask this question very similarly by talking about how would you change the pressure. And in this case, we'd want to decrease the pressure. For the next problem, we can see that the change in the number of gas molecules as we go to the product side is -2. In this case, if we want to favor the formation of product, there's only 1 mole of product gas, but there were 3 moles of reactant gas. So in this case, we want to decrease the volume or increase the pressure to favor the reactant or the product side, to shift the reaction right. And for the last case, we can see that there's 2 moles of gas on the right, 2 moles of gas on the left. I2 here is a gas molecule. So in this case, the change in the number of gas molecules is 0. So in this case, there's going to be no change by changing volume. There's no preference for the reactant or the product side, so changing the volume or changing the pressure of the reaction is not going to affect the equilibrium.